All right. So I was going to share a little bit about Fusion 360 and kind of making a parametric model. Though, and looking at the audience, I'm not sure who hasn't played with Fusion, but we'll assume somebody hasn't messed with Fusion yet and see if it's worthwhile or not. So you should be able to see my Fusion screen here. Let me grab my mouse.
Yes, we can.
Awesome. I think I'll start back with what are we doing, and then we'll work towards what this model is. So what are we doing? I should have my pictures up here now. Essentially, I went online and Vevor, they sell stuff that they can import from China and not pay duties on. So the trick is this entire website is dedicated to Chinese import stuff that is exempt from the really high import and export duties for the US. And so they've figured out ways of finding goofy stuff that people will buy that they can make a ton of money on and importing without having to pay tariffs on, basically. So one of the things they had is this wire stripper. I got it for $50 total with free shipping. So the other thing is all these prices actually include shipping. They have everything warehoused in the US. And it's supposed to be a crank wire stripper, you know, of course has 5 stars, 286 reviews. So who's to believe that there's anything that's not going to work well on it? If you look around online, though, you'll see that there's actually quite a few just complaints about the fact that it claims it can strip from 1.5 millimeter up to, I think, 8 millimeter, up to 25 millimeters, so 1-inch wire. It's a hand crank, and the idea is it's got this little like pizza cutter kind of blade and then some knurled rollers that suck the wire through, and it just pierces the wire strip, or it strips the wire on the edge so you can peel it off. They have other versions of it, like this thing kind of solves some of the things I'm going to talk about tonight. And then these are motorized versions so that you're not having to crank them through. This version, however, comes with a drill adapter. It's this little hexagonal plug here. So you put a drill in the end of here, and then you can power it with just a regular hand drill. So unless you're doing miles of wire, your hand drill will probably do the job. So anyway, this is what you get for instructions. There's supposed to be a hand crank on there. And like I said, they claim 1.5 millimeter up to 25 millimeter range for stripping, which is quite the range for having only a few holes that they've got designated for different size wires. So the problem then was if you ran wire through, the wire would just walk off the pizza cutter wheel, and then it wouldn't cut it at all, and it would pierce the insulation. So it worked great with big wire, though. It just didn't work with anything that was smaller than like pinky size, which is kind of an issue for us. We don't have a lot of giant wire. So what I ended up doing was 3D printing some guide rollers, and that's the part that's in Fusion to keep the wire trapped in the center of this kind of cone here. That way, as the wire gets drawn in, it ends up staying centered. Turns out on the knurled roller, if the roller is powered and you have a 3D printed upper, you can just keep running it until they self fit together. It just ends up grinding away the ABS plastic. So that works out actually surprisingly well for this application because it makes sure everything stays nice and tight. Here's Mark, did a nice, lovely video. I probably got just a second. I gotta optimize for video. Are you guys gonna get like half of a frame? Thank you, Google. Second. And I'll blow everyone's eardrums out with the audio too, so be prepared. All right, so this should work better. Vertical video, of course, as it's only, right?
The new hit form factor.
It seems to be.
TikTok right there.
23 seconds. It was perfect. I told Mark the same thing. Had to hit it good here. So anyway, then we were left with this though stripped wire behind. These are the rollers, and they've got a pretty unusual form because they need to fit inside on the bevel angle of the cutter as well as within that V roller on the other side. So they end up being kind of a pain in the butt. Davey did some math for us, hopefully. Davey got the math figured out.
Yeah.
So this was what we ended up with. So we just stripped a couple pieces of wire that were laying around, and it probably is a sum total of like maybe 2 minutes worth of running the machine. And we ended up with 125 grams of insulation and 255 grams of bare copper. So these were our scrap numbers previous. Now I know stuff's gone up, but I don't know how these things change in relation to each other. Essentially, number one insulated is that style of wire that we just had on screen. It's just fairly thin, but like real copper insulation. It's not like computer cables or anything, which they pay a lot less for. And then number one copper is like big, like pinky sized, big feeder wires that you'd use on like a building feed or a residential feed. And then bare bright copper is like a piece of copper tubing that's not all corroded. It's like a piece of copper pipe essentially.
So if those were pounds instead of grams, just to make my math easier,
Sure.
the number one insulated at that price, granted that price is all pricey, but I'm just assuming they're kind of linear.
Yep.
But at that price, the uninsulated or the insulated would have been $494. And then bare bright with the bare copper is $600. You add $100, you know, you're adding value.
So David is saying, if you can't hear him, essentially number one insulated at this in pounds. So if this is 380 pounds, was $494 in copper value. And if we reduced it in weight, but brought it up to a higher grade, to this bare bright grade, then we'd be at $600. So although we're reducing 125 pounds worth of insulation out of our 380 pounds of starting weight of wire, we do gain value even though we lose weight. And so whether it's worth our time, I don't know. I imagine it probably is, because it's if you have a bigger wire.
Question now.
All right, to Davey's point, we don't do anything logical relative to time for scrapping, so it probably makes sense regardless to do that. But
Well, it's a lot more ecologically sound than burning it off in the field like you guys do.
we could certainly decide to burn it off in a field. That would be good.
Well, we're getting 20% more. I mean, we normally net like $120, you know, and stuff like that when we're taking these in copper.
So Bob wants to know, what do you do with the insulation? We burn the insulation anyways. It fuels the heater, I'm sure. No, in all seriousness, we've never had it as a problem because we've never processed wire this way. But I would say the insulation waste is going to go in the trash. I don't think it's recyclable at all.
Yeah, it's like a myriad of PVC.
Is it- Yeah, it's PVC. Sometimes it's like a PLA derivative, depending on if it's automotive wiring. Some of it's Teflon. Yeah, there's all kinds of weird stuff in there.
Don't send it to California, it'll cause cancer there.
Yeah, there's lead in the insulation too. Yeah, Scott said it'll cause cancer in California, so as long as we keep it out of California, we'll be safe. So yeah, I think the insulation waste just ends up in the trash, unfortunately. Although I wonder what commercially, I mean, I think commercially they're shredding it. They probably run it through a shredder and then fold the insulation to the top and then let the copper sink. And yeah, I'm betting that it ends up in landfill anyway. So anybody got questions on the scrapping side or the machine side of that thing before I talk about fusion for a little bit?
I do.
Mr. Davey?
Your roller is pretty tight to your blade, so if you up your wire size, you can put different rollers on.
That is exactly the next point of the discussion. Dave, you wanted to know my rollers are extremely tight to the guide rollers, which means that you can't fit like the wrong size wire in there because it won't work. How am I going to fix that? And that's precisely the reason for the discussion, is to talk about why creating a parametric model to make these guide rollers is really important. Because we wouldn't want to have 4,000 rollers or have to redraw a design for every single roller. Yeah, the rollers are just squished on. I should have taken a picture of that. It's essentially a pizza cutter with a big bearing in the middle of it. So it's like take a pizza cutter, cut the center out of it, and then push a bearing in. So it's got kind of like a widened boss in the middle. It looks like, share my screen again here. I did model this. Fusion has never ever made any sense to me on how it does the let's see here. The assemblies have always been the butt for me. Where is my thing here? There we go. So it looks like this. This is just a basic model, but the cutter is the outside here, and then this is the bearing block in the middle. for the assembly. So in this case, how I'm press, I just have it as a press fit. So I gave this, I forget what I ended up doing. I took this roller, and I think I added 1% onto the diameter, and then that ends up letting me put it on the arbor press and just squish it on there. Because it's squished on the guide roller, I suppose if you ran a really big wire, you might push it off, but not really because it's pinched in. So it'd probably be fine. But yes, this is what the cutter looks like. And so my my piece has to fit on there. And then this is what the guide looks like, fit over top of the cutter. Let me see if I can get that body turned on. Oh yeah, we can do it this way. So now it's going to be harder to see, but essentially the disky thing in the middle to here, this is where the wire goes in. So the wire just runs through this little tiny gap. And then this is the guide that's 3D printed. And this is the cutter that's existing there. So in terms of what I wanted to just talk a little bit about. So if you use Fusion 360 before, essentially you're creating a sketch, you're extruding a part or revolving a part. In this case, this mostly revolves because everything's symmetric around an axis. And then you're going to 3D print it, or you're going to machine it, or you're going to do something with it. But the thing then is as you draw your parts, you're usually just doing fixed dimensions. And the problem becomes then is if you have to modify something, it sometimes breaks your model if you draw the thing poorly. And so you end up having to redraw your part because when you modify something, it blows up the model in a way you didn't expect. And when you get a lot of CAD experience and that happens, you throw it away and you just restart. And a lot of people who are new to CAD try to struggle for hours and hours and hours trying to fix the model and repair it instead of just throwing away all the work, which sounds ludicrous, but it's the easier way to do it. And just restart and redraw it, thinking about the parameter that you wanted to change and modify. So in this case, when I drew this part, I drew it knowing for sure I was going to modify this intersection angle here a lot. And then creating my model based on the fact that this thing needed to be able to be adaptable and adjustable. So if I go up here to model or modify and I do change parameters, I don't know why they buried this so far, but this is this magic interface that allows you to do a lot of modifications. So in here you can see, and I can't make this any bigger, so you have to squint if you're at home. On here, I put in all these parameters as I was measuring things up. And so some of these things you can make formulas, so you can relate things to one another. And so in this case, my guide thickness is related to the hub thickness and the spike thickness. And then I did everything in metric. It doesn't make any difference. You can convert all this stuff. And then out here, you can see the calculated value. So like here is my formula, and then here's the value that comes out. And in this case, I starred one parameter because the one parameter is the only parameter that I should be changing. Because if I accidentally change these, which is surprisingly easy to do, and there's no way to lock them as far as I can tell, you can screw up your entire model in moments and have to roll back your design to try and figure out what you changed. But anyway, if I go here, and right now I have the wire set to 2 millimeter as my diameter. If I set this to 5 millimeter, you'll see that my radius then offsets off of this point to push my wire back and give me more relief around here so that the wire can stay into the slot for cutting. And I probably ought to change it a little bit to walk this down because I don't need to be cutting through so much insulation. Right now I'm assuming that I want my wire or my cutter to land in the middle of the wire, which for stranded wire is no problem. But if I go with solid wire and I do that, it's not gonna work very well. So my model does need a little bit of updating for some things. But you can see I can go up to 8 millimeter wire. If we hit 10 millimeter wire, it's gonna start to break things. So it's warning me that my revolve is failing to solve. And so this is where I was talking about, at some point you'll break your model. When you break your model, you either have to decide that enough is enough and you're good enough. And at 10 millimeter wire, that's like almost ½ inch. We could just run it through like normal. And so I was content to allow that to happen. But what I needed to go in is go in the back here and give this thing more space to build this hub out farther. Because right now I might have the width set. So I could set this height of here as a ratio off of the wire diameter, and that would fix the problem. But the long story short is that we now have a parametric model that will allow us to go down to really small wire to just barely expose the edge here. But it keeps that curvature where it needs to be, and it'll allow the wire to go in. And this is following the taper of the existing cones that are in there as the feed rollers. So we've got these feeders on the bottom, and so this cone needs to be mindful of that. Now you'll notice that I've got a ton of plastic dust down here from grinding this off. And that's a result of the 3D printer not printing exactly what I've drawn. So I've got this drawn, this taper angle is correct, everything's good. The problem is when I go to print it, the inside of here is also coned upwards. So this inside is not flat, which would make it really convenient, but the inside has to follow the contour of that blade. And so when I'm printing this, I'm printing on this little tiny flat area here because it's the only flat part of my whole model. And that means that this is greater than 45 degrees upside down. And so I'm spilling plastic off the edge as I'm going. And so the only solution would be to print with support underneath here. And then we could make that work out and have this taper angle maintained on this end. Or we could support inside of here and then have to clean that edge off, but it needs to sit flush to that blade really well. So to me, it was more important to keep the outside screwed up and the inside clean. So long story short, it does look messy on the part because it looks like we're chewing off a lot of plastic here, but it's just a result of the edge of this thing falling down as it's printing. It's upside down. So that is more or less what I wanted to talk a bit about. I don't know.
Can you go into one of the sketches where you use one of those parameters?
Yeah, so Brian wants to see one of the sketches that I'm breaking or unbreaking here based on what I'm modifying. Let me see. Oh, there it is. I think I'm going to want to do. So the way that I've created this part is it's two different sketches. There's one here that's creating this inside edge. And it's coming up, and the easiest way for me to cut this off was just to do a cut as a separate sketch and a revolve, so that I could cut off. I could create too big of a part, and I could chop off the part I didn't want. And I'm realizing why my thing's upset. Let me make this the active part. There we go. So, and then Fusion screws this up too. There we go. So down here, you'll see all these FXs are calculated parameters. So I'm not using any drawn parameters here at all. And so like this is a function. And so that's the spike diameter divided by 2 because I'm drawing off the radius instead of the diameter. So I measured everything as a diameter, so it's the easiest way to do it. And then I'm modifying it all by dividing it in here to turn it into radii. And then this is my spike width, my spike thickness. And this is the hub thickness, which is where that bearing sits. And then just to give you a sense of perspective, this thing's sweeping around in a circle about this central axis here in order to give us our shape. And then we're subsequently coming in with a cut to cut this edge off to match those rollers. If that makes sense.
So you had to set up that spreadsheet first with the parameters so they can fall on.
So Sean's question was, am I setting up the parameters first or am I setting up the drawing first? And the answer is, it kind of depends. You can draw as you go and then you can add in parameters. So I could have made this up, and actually that's what I ended up doing is drawing it and realizing, oh shit, this isn't going to work because I need to be able to vary my wire diameter. I'm not going to be able to make this work. So then I went back and just changed the model that I already built and added in all these parameters instead. So you can go both ways. You can draw a design, realize you screwed up, and go back and change it all over to parameters. You can also build your parameter sheet first and then build your drawing off of it.
And right now, you can modify add parameter and add a parameter on the fly, which I do on a regular basis.
Yep. And so David's just explaining to make sure it's clear to everybody. If I come in here and I change this out, you'll see everything's going to change in my sketch, which is where the model is being derived from. You can also see the moment the sketch is going to break right there. See, because it, actually, right, not quite. We go above 10. It's the cut is taking place out here. So that revolved solid is removing this whole edge, and that's what it normally breaks. Since I'm editing in the sketch, everything looks well, which is actually a good demonstration. My sketch seems like it'll be successful up to somewhere around 11 millimeters probably. But in practice, once I add in that cut, it doesn't work anymore because the cut's removing the reference for some part of the model somewhere in there. But yeah, you can modify these parameters in your sketch, or you can modify them in the model, and you'll get the result in either way. So that's all our stuff working. Any other questions from anybody?
Why are you landing that wire, that knife in the middle of that wire? It seems like you're wasting a lot of energy.
So Davey's question is, why am I wasting the press down with the blade all the way to the center of the wire? And the answer is mainly out of laziness. So the wire, if you don't pierce the insulation fully, and with stranded wire, the stranded collapses. And so I didn't want to take any chances on the thing weaseling its way out. Mainly because the first time I pulled it out of the box and ran a piece of wire through, advertised at 1.5 millimeter, and I grabbed like a 5 millimeter wire and ran it, and it was like shooting all over the place. I was not content to take any additional opportunity for the thing to not work well, because I wanted to like give it the opportune, ability to cut and see if it was going to be functional or not. I didn't want to screw around with whether it was going to run. So now that I know that it works, if we do solid wire, then I'll offset the model up so that I'm not so far into it based on the insulation thickness instead of the wire diameter.
I have a second point that when I modeled my house, I would put a weird amount of energy into the windows because I put a weird amount of energy into putting the windows in the house. And so when I made the model, I wanted all of my reveals and all my stuff to line up, but I didn't want to model 24 windows or whatever. And so I did exactly what you did on a much bigger scale with like the glass and the whatever. And I made it all to where all I had to do was set how many panels within that window. And then all the parametrics would figure out the rest of it with the variables of like how wide the things were and divide this by 3 and all that. So if anybody was ever curious, I could kind of do something, go and deep dive into that.
Hopefully you guys can hear that. Basically, Davey's saying he modeled his whole house and made all the windows parameterized so that you didn't have to spend all the time drawing every window in the whole house. And essentially you could drop it in on the basis of how many panels are in the window, and it would auto generate all the trim and all the location and the cuts and everything else for it. And yeah, that's sort of when 3D printing was the super hot ticket in like 2010, 2011, everybody was talking customized manufacturing because a lot of this parametric modeling was also pretty fresh if you hadn't seen it before. So people were seeing 3D printing being super configurable, and then seeing parameterized modeling being super configurable and being like, this is amazing. We're going to have skin tight fitting clothes, which was, the hot ticket after the 90s. And trying to see what you could do, because the opportunity was there that all of a sudden you get all this customized stuff, because it wasn't so hard to be sending somebody off to literally hand draw out something and then work backwards to try and get the pieces sorted out. So it's been hasn't been quite that, but it is possible to buy really custom stuff now in a way that wasn't really possible before. So I'm going to end up sharing this model on probably Prusa printer. I think now is the cool way to do models. Thingiverse is upsetting the 3D printing community because they're requiring ads, or you have to disable your ad blocker to download the models. So everybody's freaking out about that. But anyway, I'll end up sharing it online, and then I'll probably give Beaver a 1-star review and see how long it takes them to remove my review from their ratings. And but yeah, or maybe I should go on eBay and sell little printed collars to everybody, to put in different gauge wires. That's probably the smart thing to do.
Well, I have to ask, I mean, are you gonna mill a bunch of pumps so that you can just put one, every pump for each gauge? Buy more pumps?
Yeah, so Sean's question is like, what am I going to be disassembling this thing or reassembling it? I'd say a lot of the wire reprocess is the same size, but it turns out actually if you run too small a wire or too big a wire through, you can just loosen up the pinch pressure a little bit. And it actually is pretty cool because it slits into the copper and then it squeezes the insulation out of the way as it's like jamming its way through, up until the point where we're going to kill the guides. But I'm wondering if I make them out of aluminum or metal or something and put them on there and glue them on, if it's not just going to smash the insulation all the way and slit it as it goes, which might be kind of a win that way. But
Well, so I guess that leads me to my second question. Have you tried running a thicker gauge wire through the print that you have right now?
yeah, my first video with Mark was running a thicker gauge wire, installing the drill, and then we didn't record it, but I was testing it just before I grabbed them. But yeah, and then I loosened it up a little bit and it ran fine. So I think there's some play with it.
Well, I mean, so that means in theory this would probably work for any wire gauge.
I don't know. Yeah, it might. I'm not sure. I'll have to play with it. See, or if anybody wants to mess with it, go for it. It's not. You're not going to hurt anything. Any other questions about scrapping wire and the inefficiencies, wasting your time with it? Or if anybody's scrapping out houses or anything, bring your copper over, road copper party.
We just need to solder them end to end, so you just get it started.
Exactly. Yeah, braid them and run it. All right, cool. Matt, are you here? Maybe not. All right, I think Brian's up next. So Brian's gonna give us an update on his hydroponics system. Let's pull up all the relevant bits here. All right, you want me just to
Just show the screen.
sure?
It's fun.
Oh,
All right.
mouse and all that makes life easier.
It's never easy. So this is an update on, if you were around last month, you saw me talking about this hydroponic system I was kind of working on. I started off from basically this website. It's kind of a guy put together a kit. Let's see if I can give you a kind of overview here, just so if you didn't see it. It's kind of made out of these PVC fence posts. I'll say this one. Yeah, so it's basically you take a bunch of PVC stuff and glue it together, and you make a lot of these components. Yeah, so it kind of looks like this. So this is like two ways. So what happens is once you put this together, you have a water intake that flows underneath your net pots that have your seedlings in it, and then there's kind of a return, and then it goes down into a reservoir underneath the system that just keeps cycling over and over. And inside your reservoir, you have your water with your nutrients in it, and an aerator to aerate the water as it's going over. So that was kind of my base setup. I got some pictures here. So this is kind of what it looks like when I had it all done. So you can see I kind of have 4 things here. You can see some of the plants going. So the idea is the first rail here is kind of where you start them off. Then as they get bigger, they go to the second one. And if you have longer term plants, you go back here. So I have my little light rig on top here. It's inside this tent that's basically a foil reflective thing. It's a grow tent that you get from Amazon, and when you get it, there's lots of marijuana iconography and stickers in the box, and that's where you get the stuff from. So the PVC was from the Home Depot. The reservoir is just a thing from Menards. You just get stuff. You just get like pond pumps and things like that. So as you can see, there's stuff growing here. Nothing fun, just your vegetables. I don't know, how do I go back? There we go. So let me go back. So I got some sort of just basic, I think it's like butter crunch lettuce. So this is about where these were, I think, last Wednesday. So I'll kind of go through. So you can kind of see when I first started, I was just putting the seeds in there, and the stuff's in my basement. The temperature in my basement's about 50 degrees. It took just putting the seeds straight in, even though in my water reservoir I did put like a aquarium heater in there. It still wasn't heating up the seeds enough to actually start germination. So these are kind of the earliest ones. So you can see this is about last Wednesday, and you can see they kind of get bigger, and you can see, oh, the roots are getting bigger. And as the plant gets better, you can see there's like a little tomato plant that I was able to start there. And it's just kind of like as it goes. Later on, I moved to taking a seed starting tray with a heated mat and using that to start the seeds inside of just a little tray, and then I would transplant them into the pods here. So one thing you're looking at here is some of these pods have like green on top, so that's algae. So this light system, any nutrient liquid will be algified quick. So it's you got to manage that. So hopefully when you get to the point where your leaves kind of block out the light as it comes in, if you also notice these little blue caps over these holes, so these are little 3D printed covers, so the light doesn't get into the water and start to algify the water. So that was another thing. When I first, let's see if I go back, my little seed starting tray, initially I was like, oh, I'll just put it up here. That'll get warm enough. And again, I just grow algae inside of there. So once I moved it down here, it cuts down the algae a lot. And and once I put the heating pad on there, it started to quick. So that's kind of a thing you gotta figure out. It's like, how do you get your plant started quick and not grow algae in the process? So, and in his website, he talks about that. So,
Consider just eating that algae.
what's that?
Consider just eating that.
Right, yes. This is not a Soylent Green scenario yet. We'll see if the world keeps going in a direction. So hopefully I'm not ahead of the curve here. And
It's already in the basement. You're good to go.
yeah, right, exactly. So here you can kind of see, kind of close up. It's like, okay, there's a seed in there, but there's also some algae around there. But you can start to see there's a little bit of a wisp of a root coming out. So that's kind of the interesting thing is these roots you can really see the roots growing. This one, so these dirt type of things, I think there's some sort of like peat pellets or something. I've also had this like rock wool stuff, which is like a glass, fiberglass. Yeah, it's a fiberglass substrate. I had it from years ago. It's like I'm trying stuff, and again, you can kind of see the green because it's also growing algae. You can see it a little bit better here than on the, but you can start to see. Okay, there's some roots coming out of this tomato plant, and there's so this is I think Saturday or Sunday, and you can kind of see from just like a couple days to that plant, and well, maybe that was today. I don't know. Yeah, that might be today. So, so this is about a week after we go back to the beginning. It was like that, right? Like, yeah, this is literally a week ago. So this plant that had the roots that were like this eventually get to this. So these seem to be going gangbusters. I also had this anemic chive plant that was in a pot. That again, in my 50, 60 degree house does not really take well to it. So I was like, all right, let me take out a subsection of it and put it in there. You can start to see all the little white roots are kind of the new growth. So you can like the brown stuff is what I pulled off. And again, it's been about a week that's been in there. So that's just something to transplant in and try to make it go.
So you end up planting them, and I guess you have to get them out of the plastic pot at some point.
Yes,
Cut it off.
right. So hopefully at some point in time, when I get to the end of this, if you go to the supermarket and you get like there's like a Boston bib that's in a plastic container, and if you get that from the store and you take it out, you'll see it basically has this plug on the bottom of it. So they're kind of doing this type of thing. So one day I'll do that. Hopefully, like another month and a half or so, I'll be able to say, hey, see when you buy it from the store, this is kind of how they. So
So I didn't follow that. How are you gonna get that basket off the plant?
I don't eat that part.
Well, I was gonna say, when I do my microgreens outside in the spring, I'll plant them really dense,
Uh-huh.
and then I'll come with the scissors and trim them.
Right.
And I can do that 3 or 4 times, and the regrowth is like a 2-week cycle.
Okay.
Or I mean, almost like by the time it gets to the end of the row, I can start another end.
Okay.
So, I would say like play with something before you just rip them out of there. Like try to prune them, leave enough green there. That they
Right.
grow, but you can probably get several harvests.
Yeah, there. I did do some leaf lettuce as well. So for something like that, so.
So you won't have to transplant that to a different pot that's bigger to handle the bigger plant.
No, well, according to the guy's website, this can go from this to harvest.
Okay.
So that's my understanding. Because
What are you doing for light cycle?
I just leave it on for like 14 hours, 12 hours.
I bet you would decrease your algae by keeping on 24 hours.
Okay.
At this stage in the plant's life, you can take it. I
Right.
think it's only as it gets older, or it's flowering or other types of.
So you're saying if I keep the light on longer, I will decrease algae?
Well, because you're gonna increase the warmth
Oh,
and then you can get those leaves bigger faster.
Okay.
The damping off is the bigger concern than algae, and that's that fungus that lives in the soil with cooler temperatures. I've had that issue in basement before, but I almost lost all my tomatoes last year when I sprayed all the soil with vinegar. I tried to avoid the tomatoes, but I was told to experiment, but it worked. I
okay,
don't know if it would work with the algae, but
okay.
I mean, it doesn't look like it's a problem.
Yeah, I mean, I've read other things of people using a, oh, what's the thing you put in your wounds to clean out the wounds? No, hydrogen peroxide, right? You
Yeah.
do like a real light mix of that,
Yeah.
and that's also a way to astringent something that you don't want, right?
So, yeah, I think it's just getting, and then another thing you could try is just airflow, getting a little fan in there.
Yeah, so I do have a fan I need to put it. So once things get bigger, then yes, I was gonna put a fan in there as well. So, and then on the bottom here, so you can see on the bottom, it's kind of like my little warming tray. And this is how I'm just doing them now. So I just germinate them. I get these little to-go containers. I put a little bit of paper towel in there, wet it just enough to dampen it. Put the cover on. There's a little thermostat here. I set the temperature to like 75, 80 degrees. And that seems to be good till we start the seeds. But once that they start, I basically go and get a little one of these plugs and just with tweezers drop them in. And that seems to be working well so far. So that's the process. Hopefully I get a bountiful harvest. Part of this is to, start seeds for gardening. So I'm kind of, even if I make tomatoes and I was like, this is not, I'm gonna throw them away or something, it's fine. I'm in the experimental stage, so.
Right at the chat at the top.
Yeah, any questions, I guess?
Oh, that's the other bad.
Matt's here, all right. So yeah, that's what I got. Anybody, any questions, I guess?
So what did you get from simplegreens.com or whatever, just the plant?
Yep, this guy that, as far as I can tell, is, lives in Wisconsin somewhere. Through internet sleuthing, he's a graduate from UW-Platteville. He's an engineer. If you look at his drawings, he's an architectural engineer because he did a good job drawing them up, and you can see it's kind of all spaced out nicely. So
Are you up to 3,000 your field plan there?
yeah,
I'll shoot him. I'm saying he's got a drawing. He better be.
okay. I get the gist. Yes, right. You can't he does this and he has like YouTube videos of like putting them together. He did everything and he sounds like an engineer when he talks. It's pretty hard not to mess up. So like there's when I've seen it like other stuff, it's always like, oh, you can make it out of anything, and then they get really deep in the woods of like, oh, this type of fluid with this mix of that mix and that mix of it, and it's like, ah, come on, this is too much. This guy is just like, nope, I'm just trying to grow lettuce for my family. Here's the dumbest way I found out how to do it, and it was just well put together, and it's step by step. You can even see it's like he goes into the how to make a wood structure for it, right? I just had a bunch of like it goes through the reservoir, right? Like I got the same tape. The pipe sizes, right? If it's this many feet off of where the reservoir is, you need a pump to push it so far up, right? He talks about lighting, right? He's done all sorts of different stuff. Here he talks about the nutrients, where he got his. Other things, it's like you want to condition the water. If you're taking from a city tap, there's a solution you can get for fish that will neutralize the fluoride, I think it is, or chlorine. Or if you have pH problems, you know, it's just kind of like step by step. You know, here's the planting system, right? Talks about the seeds and everything. It's just really like, and here's like his process of like, I plant as it grows, I move them this way, and then I have the maturation or harvesting level as the plants get bigger and that type of stuff. So even talking about harvesting, let's see, do they have a picture here? No, all right. So yeah.
Is aquaponics the next evolution here? So you have a fish tank.
Oh.
Pumping through.
Yeah, I don't need pets.
Okay. What's food?
You got pets, man. You got the plants.
I
Pets.
don't really want a gut fish. It's just I don't like doing that.
Okay.
I'm gonna eat a lot of tilapia then. Okay, I guess that's probably gonna be the fish I have to eat, right?
Yeah. It's a pretty cool setup.
So
There was a restaurant in Kansas City that when you ate their lettuce or whatever, it came from the basement. And they had, like, you go to South Service.
all right.
I feel like there's like this, we had this thing on the farm, we would track growing degree days for like corn and stuff like that. And the relationship was pretty well understood between like sort of the plant maturity and growing degree days, where temperature above a base threshold actually matters. I don't know if that's something that they do with hydroponic systems, like is there an idea of like warmer is better or above?
Well, yeah, they talk about, especially when you read the marijuana shit, right? Because you're moving the plant from seedlings to vegetative state to a bloom or whatever it's called, fruiting state. Yes. So and then they really talk a lot. I was like, oh, you gotta change your nutrient things for levels. Yeah, it's something you can read about, I guess. Like my basement is the same temperature pretty much year round. It's gonna be 50 or 60, basically. So it's gonna be, I'm gonna be able to control as much as I can, depending on how much airflow I allow down in there in the summer.
Yeah.
So. Okay. All right.
Thanks,
Thanks.
Sorry, Matt. I didn't realize you were Matt F. Anybody else have anything they wanted to share? Well, I think that's all we had for tonight. Dave, you gonna do it? You got shiny things.
I mean, I'll show it to you, but I don't
Yeah,
have
let's see
anything.
it.
Huh?
Oh, that's fine. We don't need all your knowledge. We just need the fact that your machine still works in the garage.
Yeah, okay. I'll give you an update, and I want to do a full,
This is like a tease. That's all. It's
Yeah,
like a
yeah.
pitch for.
this is the trailer for my meeting, my next month's, hopefully next month.
Picture's gonna go good.
Yeah, so I got a big fancy machine in my garage and I'm making batarangs with it, which has been pretty fun. The whole is because I'm just using like whatever offshoot of, aluminum that I have.
Stolen from scrap night is what it is.
Well, I mean, hey,
Noticing our profits.
I've been hoarding metal for a lot longer than I've known you. This is probably older than Sean. Anyway, so this has been fun, mainly because, as you can tell, it's chamfered on all sides except for right here. And so typically when you're machining something, you put it in a vise, or you have some sort of work holding that clamps it to keep it, because you got to keep it from moving around so you don't break bits because they're expensive.
And you don't want to re-index it too many times.
Yeah, right.
Re-index.
Yeah, so we're multiple operations. You have to tell the machine, where your part is so that it can know where to cut. And so basically what I figured out with this, with the help of, it helps that I work with, career machinists. And it's funny because in October, I sat down with one of the guys there and I said, okay, I want to make a batarang. Here's my plan. Here's the file, the 3D object. How do I do it? And he rambled a bunch of stuff at me and I was like, okay, check. And then I left that like confused and not really sure. And it took months to like really process all the words he said and figure out exactly. And I had to try a bunch of stuff mentally and physically. And I was trying to like toe clamp this thing with like 8 different operations from walking things around. And, anyway, what I've settled on, which has worked, I'm up to like 15%, I think, success rate, is to, put it in the machine flat and, just a sheet of aluminum. and then mill out the profile, but not all the way through, so it's still stuck to the bottom. You know, I'm only going 3/4 of the way through to keep it attached to the billet of material. And then I cut the top chamfer around, and I'm just showing the camera here, I'll show you guys, just around this outside, just the chamfer profile is what I detail or I cut, and I'm using an actual chamfer bit for that just for ease of machining. And then all this is still tabbed to the stock. And then I bore a hole right here that's 0.4 inches in diameter, and it really, you know, it's 2.5 inches off of center and 1/2 inch off center. And then, so then when I flip it, I can index off of that hole, and then I do the same operation again and do the other side, except when I'm flipping it, I'm super gluing it. So you glue painter's tape, glue painter's tape, super glue in the middle, squish it down, and then I have a little fixture that has a flat rail on it, so I can push this up. So I get my plane there, and then I have a, you know, index hole here. And then if all goes well, which it normally doesn't, I get to, you know, I cut the top chamfer in much the same way I did the bottom one, and then I go through and I cut this last bit out, and then just kind of pop the super glue off. And so I've learned a shitload. I've broken a lot of bits. I've wasted a lot of material. I think I've tried this 12 times, 11 times, and I've got 3 to show for it. I actually quit paying attention to my layout. When I first started, I would worry about this hole, and like, you know, there's another one in the ear that barely is, you know, I quit paying attention because I kept, you know, mashing stuff. But anyway, there's a bunch of stuff I learned. I think the biggest one, which is like really super obvious when I say it out loud, but like when I was in the throes of it, it took me too long to figure out. I was using flood coolant on blue painter's tape. And so that was just like peeling the adhesive right off. I had other issues with like cold material and the tape wouldn't stick. I actually went back and superflied one side of this so that it's like ball hair smooth instead of like kind of a ridge here. Anyway, I hope to update next month when I can show you some pictures of the process and my 5-gallon bucket full of batarangs, because next step is to huck these as fast as I can at some sort of foam target to see if they stick. And that's because I have so few, I haven't even done that because I don't want to ding up my precious, you know, little piece. Anyway, so that's what I know. And for a fun fact, Fusion has no idea how to do a chamfer, or maybe I have no idea how to tell Fusion how to do a chamfer. And so I actually did the first several iterations of this using Path Pilot Conversational, and just because I knew the what I, you know, I knew I needed to cut 32 thousandths off the side of this to get my chamfer bit in the right place, and I knew that I needed, you know, 30 thou depth of cut each time because I didn't want to hog it out. Anyway, after just way too many tens of hours, I think I figured out how to fudge Fusion into making this work. But I've yet to get it to do what it's supposed to do, where I say, oh, there's a chamfer there, and it goes, oh, check, got that. It doesn't. I don't know. There's voodoo magic with chamfering. FYI, if anybody wants to try.
Is that because it's a spline?
Yeah, you can chamfer. Fusion really wants to chamfer a hole. Like you can select chamfer, select the hole all day long. I can chamfer. I could select a line and say chamfer this line, but I can't do multiple depths of cut. It just does it one hog pass. And especially when I'm holding with super glue, I have no idea how hard I can push it. So I'm just doing skim cuts, you know, and like I slow the machine down, you know, I do about 60% of the feed rate on the super glue side as I do on the clamp side. And mainly because it keeps popping. And so once I kind of figure out my work holding, I'll probably increase that until to figure out where that line is.
Interesting that we want us to speed carving.
Yeah, right.
So if you, I don't think Fusion implements speed carving yet. I don't know why.
Yeah.
Because it's super desirable for all woodworkers because you can actually beat carve successfully. Because that metal doesn't work if you go down. Well, I should say it doesn't work. It's very hard to get tool loading in the center because it's got no effective tool diameter.
Oh, right.
Because it's just mashing its way down the middle.
Yeah.
So you have enough stiffness, you don't care. But if you don't have stiffness, then it's a problem.
Yeah, I mean, that's a good point. And that's Fusion just wanted to do one full depth of cut for the chamfer. And it would do that, but it wouldn't, I couldn't say like, as soon as I selected a chamfer bit, it wouldn't let me do multiple depths.
Yeah.
And so I actually made a dummy tool that's 64 thousandths of an inch in diameter because I wanted the tool tip to be 32 thousandths off. And then I could do like, just tell it it's a 62 thou end mill, and then I could do depth of cut and set up my feet and speed however I want.
Cool.
So anyway, yeah.
Thanks for the preview.
Yeah.
Curious where that gets stuck in the building somewhere, right in the
Yeah,
concrete.
these cardboard boxes.
I've got a nice pneumatic tube upstairs with a shoot the ball valve coming out of the end of it. I bet we could shoot that.
Oh,
pretty-
nice,
pretty
like a blood
fast.
cannon?
Yes. All right. I think that's all we got. So unless anybody else has something to share, I'll kill off the meeting here early and send everybody home for bed. All right, doing it.
I've seen people make a fixture